Yes.
How can we judge on the data there is have a bias or not? Because I finished the first step. I told you.
Which step? This step?
Yes.
Exploratory analysis, right?
Yes.
Ali, right? Ali?
Ala.
Ala, okay, sorry. Ala, did you check this document?
Evet.
Okay, good. So do you have any questions or any problem?
Little yani.
Okay, so what's that? Did you try to install those packages?
Evet, evet.
You did?
By plot C4.
Okay, C1, but still you need this. So how about this? Couplings?
No.
Did you?
No.
So, but this one, how about this?
I think this after the training module.
Yes, but I hope, yeah, after the trend, no, and not after the trend models. We want to integrate it into the model. Yeah, because this is very important.
But it's not in the first one.
Yeah, we are all these stops, these ones, we were not working with this ones at the earlier stage, at the first stage.
Yeah.
We want to make use of it at the middle of the process. But we need to ensure that we can put all those libraries and we ensure they are working well for us. So did you try all these libraries?
I tried a little of them.
Okay. So what are your challenges?
مثلا AI بجرافيك بروسيسنج يونت كومبين يعني يعني
combine
دمج
combine.
يعني can you explain more than
about which part?
الذكاء يشرح
يعني ما تركي انجليزي
No problem.
بان
Just
شكر
try.
شكر
Just
شيء
try. You have to try. Just try.
مثلا نيفيديا بروسيسور
What's the meaning of NVIDIA?
NVIDIA company for the graphic.
NVIDIA? Oh, NVIDIA. Yeah, I know.
NVIDIA internal مثلا.
What is going on with the NVIDIA?
ايش اللي بيصير؟
مثلا بوكم يعني this company AI now internal المعدات تبعتها للبروسيسنج
اي
البروسيسور تبعها.
So do you have any problem with? Do you have problem with your NVIDIA or with your processor in computer or?
أو بحكي إنه في عندك مشكلة في الكمبيوتر أو
what is the okay so what is the
ترخيصه يكون كيش
يعني مثلا كاجلي الموقع كاجلي ويب سايت now more Python library يعني graphic processing unit with AI. بدي بس افهم انا العلاقه بين بعض الاي اي والجرافيك بروسيسنج يونت. علاقه معناها الدمج اللي حاصل حاليا، لان انا ما فهمتش بالضبط كيف هم دمجوا الاثنين مع بعض. يعني كيف صار مثلا شركه انفيديا بتصنع بروسيسور قائم على الذكاء الصناعي.
So what are the challenges now? I just want to know the problem. What is this problem?
problem يعني I am trying to understand the now how graphic processing unit with AI work.
Okay, the GPU, right?
With GPU.
So what is important is this is about this work in this library, this complete laboratory. Actually, we don't need GPU, that big GPU, because the data set is very small, and the data set is small, it's not big, because looking at this data set is small. And then as well, the libraries we want to work with, like this it's a basic machine learning. So basic machine learning libraries actually do not require any GPU. Like this one's, let me show you. Wait. Where is it? You can see all these libraries. You can import all those. You see, all this method does not require any GPU. This method, like F-test, these are the statistical method for feature selection. F-test, mutual information, variance threshold, chi-square, correlation, ANOVA, LDA, and then this wrapper selection method, forward, side, backward. All this, we do not require GPU, right? So because these are simple libraries and they are not having any much difficulty with our data set. But let me show you something. And then also, if you want to use these approaches for controlling class imbalances, you see we have random undersampling, cluster-based oversampling, synthetic minority oversampling technique, that is SMOT. We have modified synthetic minority oversampling technique. Then there is this ensemble, bargain boosting, you see. So all those techniques are very easy. I can show you how to use these techniques. So these techniques are easy. They do not require any GPU enhancement or maybe GPU utilizations. So then lastly, this is the Watson machine learning from the IBM. And also these ones do not require any big processing.
Yeah,
so I understand your questions. Let me just tell you something, please. So you see, we use GPU basically. We use GPU so for faster processing, and also if we want to process data in batches. We want to do a parallel processing, like we are processing two streams of information. One stream of information is processing independent to another stream of information or data. Like if, let me show you, if for instance we have, this is our data, this is my data, right? So I have bunch amount of data. Let's assume this data is up to maybe 20 GB. This is the size, the volume of the data. So I want to process this data. Basically, if I'm using the CPU, that is the basic, the standard CPU, classic CPU, for this data, maybe it may take me like, maybe to process, it may take me maybe 1 day, that is 24 hours to process. Yes, just to process this data. You take this data, you process this, you won't get the output.
ونورمال سي بي يو
Yes,
كور
yes.
اي 7
Yeah,
مثلا
normal CPU.
نورمال
So good. So now we try to see how we can utilize this GPU, graphical processing unit. So So with this, we have some kind of enhancement, or there are some enablers. You can make one out of the two. Whether you can take the whole data set, this data, you take it here, you process it along this. So instead of having this, if you can process the whole of this, maybe you can finish this within maybe 5 hours or 3 hours. You can finish this because of the processing capacity, where it gives you like, instead of just taking in this process, it's taking like the whole data. Let's assume this is our data. This is your data. It computes the entire matrix and now give the output. But in these situations, it is now make the data in form of some kind of batches. Makes it in some kind of batches to process, so that it can process each data instead of to read each instances, which takes longer time to process. It will now like taking some data in some kind of a very effective strategy. It will organize it in such a way that it may easily see the patterns, it may easily learn the structure, it may easily explore the content with a context without wasting a lot of times to check into each point. So this is what gives it a capability of making a fast processing. This is in the first stage. In the second stage, it can divide this data into two kinds of stream. Which is stream 1, stream 2. So in this kind of stream, maybe it can take some amount of data just for pre-processing. In this stream, they are just only making the pre-processing. While in this situation, it is now doing the processing. Like maybe in this processing, maybe like it is trying to do some feature extraction. In processing, as maybe some feature extraction or maybe feature engineering. And then there is this kind of mapping. So it can do this in parallel. This is what we mean by parallel processing. The whole of this process is what we call parallel processing. Do you get the point? So this is the advantage of using this kind of tools. Instead of wasting this 24 hours, like one day, processing this 20 GB, for instance, just an example. So, but if you may be able to have this GPU, so you may be able to make this processing within a very short period of time, maybe within 5 or 3 hours.
It's very important.
Yes, very, very important, because it has this kind of strategy. You may use this, and also you may use this. So this is the most pronounced and also significant applications in the deep learning, because most of the big generative transformers, like the transformers we are using for this GPT and rest of it, they are working on this kind of principles in parallel processing, because they can process different kind of informations at different streams, different channels. It is doing this channel is doing pre-processing, while this channel is making some kind of processing, and then another channel is trying to make some mappings or maybe doing some other important task. It's based on how you can. So you can divide your task. You can divide, if you have this kind of task, you can divide into n number of tasks. This is what we call jobs. So you can divide your task. You can divide your task into different segments. just like think in your room, in your house, So maybe in your house you have a lot of tasks. Maybe you have cleaning, you have to clean. Then you have to maybe arrange, you have to cook food, you have to take children to school, you have to do some homework, you have to read. You see many tasks. So instead of you alone to just do the task, so you can divide the task. You can assign, okay, you are my wife, do the cleaning. Oh, child, come, fix this. I am the boss. Okay, let me take you to school. And then you go and do the homework. So you can divide the task into different segments, you can assign the task to different kind of people or individuals to finish it within a very short period of time. So this is what we mean by this parallel processing. You can divide the task into a number of jobs. How many and at what distance, at what processing unit or processing models you want to make this task. So this is exactly on this kind of a stream instead of, so you can make in this kind with this capability, you can do some kind of task in the GPU and then some kind of task in the CPU. You may divide the task. Maybe you can ask the CPU to do pre-processing for you, and then you ask the GPU to do the main task for you. That is the process. So that's it. So let's go back to how we can judge our data set. So let's see fairness. Every day we talk about fairness. Okay. Let's see. First of all, we need to learn this techniques, this tool first, because we have two kinds of tools. We have AI 360, then we have Match 360. These are libraries in IBM. We have these two kinds of libraries. We have FAI 360 and this one. They are and Match 360. But first, now we are interested in using this kind of library. So we need to study this library so that we can integrate it into this task to see how we can control and judge that we have yes. Though basically by descriptive analysis, based on our descriptive analysis here, we observe that there is
string.
What?
String. Descriptive.
Yeah, descriptive. When we say descriptive, statistics, like if you have an Excel sheet, let me explain it. In data science, when we talk about descriptive statistics, we are trying to find some insight of a data. Like you want to find some basic information of the data, like how many columns, how many rows, how many features, how many instances, then what are the mean, what are the media, what are the modes. Yes. Yes.
And
so this is
we
what
check
we call
the descriptive.
Yeah, this is what we call
Descriptive method and descriptive.t.
Yeah, descriptive.
Yes, descriptive that work with numerical column, numerical data.
Yeah, it can use with actually numerical times, and we can make a little adjustment also sometimes to work with
.t to work with string data.
Yeah,
and we see so.
Yeah, so this is why you can use in data science, you can use the function, or in the exploratory analysis, you can use describe. You can write describe this function. You can use this function so that you can see the basic insights of your data. Or you can use this. We have utilized it.
Describe.
So just like
a second tool, Match.
Yeah, Match 360.
And we will choose the first one.
Yeah, we are interested in the first one, though maybe some applications they may require the second one, but I'm interested. So you can see just like this one. Sorry. Okay. This is
yes, there.
Yes,
here.
this one.
Yes.
So this is the descriptive statistics.
Yes.
We want to find the description of the data set, the basic information. You may see how many number of instances, that is the number of count.
Yes.
You have 1,470. Then you may see what are the unique values.
Yes.
At each feature or at each column. This column is what we call features. So how many count, how many information do we have, and how many are unique? And then also we can see the top features. Then we can see the frequency, that is the number of occurrence by each instance. Then we can see the mean, that is the arithmetic weight of each column or each feature. Then we can see the standard deviation, that is we can see a little bit amount of basic dispersion. Then we can see the minimum value, what are the minimum value. Then we can see the 25% of the interquartile. So then we can see the 50, 75, and then the maximum. So this basically, based on this, we may have some insights, but to get it more to understand the situations is to understand the behavior of this data set is very important to have a broad visual description. You have to visualize the information. You have to visualize to see what is going on and what are the number of counts. But basically, based on this also you may see, like if you look at this, in this you have the edge. Where is the number of count? 1,470, right? Okay, this is the total count. Okay, let's start with the edge. You can see the minimum value. Where is the minimum value? 18. The maximum value is 60. Let up the attrition. Why is the minimum value of attrition? There is no minimum value. And then the maximum value is also non-assigned. Do you know the reason why we have this?
Yes.
Yeah.
I think because it's
categorical.
Yes.
Because it's not a number.
Yes.
These are non-numbers.
We should do a script.t. So
yes, but do you know by this package actually we are just utilizing and visualizing the numerical values so that we may be able to understand what are the capability of this library. So it's good for you to understand this basic, because you know, oh, if I use this I may end up misguiding the models, because if you don't know that you have some categorical or maybe you have some ordinal scales in your data, you may not know, so you will just start developing your models without looking at this kind of situations, which is going to give you an error. It may return an error while modeling. Maybe it can say there are some maybe undefined characters or special characters that the model cannot handle. So this is very important in the pre-processing stage, to know you have the categorical variables, you have some ordinal scales, you have some qualitative values which they need a very special attention, or they need some special treatment. So this is the reason why we have this. So let's move quickly to this. So from this you may be able to see that you can visualize if you have some missing values. What are the missing values in each? So this is you are trying to find. Like in edge, you don't have any missing values, because once you see 0, yeah, it is showing that you don't have missing values. So then we move quickly to see how many columns do we have. But these columns are just to show you the columns with string values. Column with string values. You know the string, right?
Yeah.
So we want to see that which columns are having this string. That is the reason why if you look at this description, you can see where we have this non-assigned number or we have none, is the places where we have those kind of string values. Though basically some columns actually we have the numerical values, but because there is some noise in the data set, so some values crumbles within the data set and also find their places in some columns. Just like if you look at this, if you look at this, you can see we have only attrition, business travel, department, gender, job role, marital status, and overtime. You see, we have only 1, 2, 3, 4, 5, 6, 7, 8. We have only 8 columns with this kind of string. But unfortunately, if you look at this, you can find some in environment satisfaction. Which environment satisfaction, actually we have what? We have numerical values, but we may end up having some kind of a string. So this happens because of the noise in the data. So that is very important. You should do this kind of analysis so that you may realize what and what you have and what you want to utilize, and what information that need a special treatment, or they need to further processing, or they need some kind of manipulations. So if you check on this, so this is the why we have to make some special encoding using this transformer, which I have explained how this encoding was happened last time. So we don't have to waste our time on this. The important things is we want to see this is going to bring the correlation. What are the relationship? And we have described this last time. We don't have to waste our time. So this they are trying to see how they can filter some data set. So they filtered this column, that is monthly income, total workings, this, because basically based on this correlational analysis, they found some information that are correlated, while some they are less correlated. So that is the reason why they make this filtering. They try to figure out those columns that are having correlational values. So on the edge analysis as well, you can see we have this as I described last time. Then they try to calculate the number of counts amount, that is to quantify the ages at each range. You can see we have that is why they use bins, that is the histogram to quantify. So histogram is a very good tool in using this kind of quantifying this kind of relationship. So then what is this one? Okay, this is they use C1 to find the relationship between travel and versus attrition. The attrition itself and the travel. What are the relationship? Look at the count. You can see the green, the blue is the attrition, right? So the attrition, there is attrition, no attrition, there is an attrition. Relationship with the travel, in the travel. So in the business travel, there is possibility of having attrition or not. Okay. You know attrition, right? So if you look at this, you can see in business travel alone, blue, you can see the chance of not having an attrition, you can see is very high. It's around, how many count? 887, around 1,000. But having and not having an attrition, then having an attrition, you can see we have only 156, which is, this is bias in the data set. Yes, there is bias because this class is dominant against this. Because this class is dominating these classes. Because look at this, the data is skewed. If we can plot this, you can see we are going to having a skewed distribution. You can see. So this skewed distribution is very important to look. You can see. We may end up having something like this. This is skewed distribution. So skewness is a very significant issue in data science. Because if you plot this, you may end up having this. You see, this side is skewed. It's skewed. So there is possibility if you make this model, there is some possibilities that the dominant classes, the classes with high magnitude that is having a much values, they may dominate the classes with less instances or less values. just as in this case. Because if you can develop a model with this kind of situation, there's possibility these classes must be dominated or ignored. The models might ignore these classes. Might ignore these classes. They might possibly
Ignore?
Yeah, ignore. So it may concentrate. What I mean by ignoring that is it may concentrate on the high classes and then just refuse to take it into consideration those little or maybe minority classes. Do you get the point? Like just now, do you remember last time you told me you have a value of maybe, let's assume you have 12,000 in one class. You have 12,000 for feature 1.
10,000.
Okay. Okay, let's
gender.
Yes,
Yes.
you have 10,000 in one gender.
Yes.
And let's assume this is
I
female.
have male and female.
Yeah, let's assume this in the males. You have maybe around 5,000. Let's assume you have this. So then others. Let's
Yes,
assume
other
you have
it's
maybe
like
5 or 10.
19.
19. So you see, if you try to build a model based on this kind of information, the model will concentrate on only these two classes and discard or ignore this.
Ignore.
Yes, you can ignore this.
Yes.
So this is what we mean by the effect of this skewness. And sometimes ignoring this is very bad. It's biased. It's unfair.
Unfair.
Yes, it's unfair. Because we need to incorporate this. We need to, just like in this university.
It's normal to be unfair because it's like I'm 19 years.
It's not normal. Yeah, it's tradition to be unfair, but it's very unfair to be unfair.
It's what?
Yes, it's traditionally, basically, we have to be unfair. But in a normal sense, we shouldn't be unfair. We should be fair. You do get the point?
Yes.
We should treat everyone equal. Just like maybe in this university, we say, okay, let's take the population from people from Middle East, people from Europe, people from
America.
Southeast Asia, Southern America. Maybe the population will give you something like this. Let me visualize. People from Middle East may get something like this. Okay? Okay, let me say, people from Europe may get something like this. Am I correct? The population in this university. Am I correct?
Yes. From Europe.
Yeah, Europe. This is Europe.
Yes.
Europa, right? In Arabic, how do you call it?
Europa.
Okay. So then this is Middle East. Middle East is, what is the name? Middle East in Arabic?
الشرق الأوسط.
الشرق الأوسط.
Uh-huh.
Okay. الشرق الأوسط. Good. So then let's talk about people from Southeast Asia or from Asia. Maybe it can be somewhere around here, right?
Yeah.
Okay. Let's talk people from United States in this university. Maybe you can find something like this.
Yes.
Am I correct?
Yes.
Okay. People from Africa. Maybe you can find somewhere around this, right?
Right.
From Africa. Okay. From South America. You know South America?
Yes.
Okay. Maybe we can get something like this. Am I correct?
Correct.
Okay. So if you look at this distributions, and we really wanted to see the impact and the influence of teaching and learning in this university, so we have to carry everyone along. We have to carry all the distributions so that you may see what are the impacts and the influence of our teaching process on each and every of these distributions. But if you just say that, okay, I want to assess my teaching and learning space or environment, you just say, okay, let me just consider people from Middle East, people from, where is this? Asia, where is this? Africa. You just consider only these three.
Yes.
You ignore this. So you are unfair because you may not actually capture your complete systems. So yes, you didn't, because this maybe might this maybe you can say, okay, maybe this place, these ones you ignored, they provide you with more significant impact compared to this population. You get the point?
Yes, keep going.
Maybe let me.
So in this system, what we should do?
Yes, we have to take everyone. We have to carry everyone along. We have to take everyone. Everyone is important. It's a potential candidate. Everyone here is a potential candidate to our modeling. So we have to carry on.
What do you mean? We will take everyone.
We have to take everyone.
Yes.
How?
Yes, how?
Good, great. This is a great question. This is what we are concerning, how we can take everyone. That is our concern. But we have to take everyone. Why do we need to take everyone? This is what I want to highlight. Because maybe someone here, I'm just guessing, that does not mean correct, just a guess.
Yes.
Let me guess. By examples, maybe people from Middle East, they're having the majority population, right? Let's assume we have 10,000 people. 10,000. Let's assume we have 10,000 people from Middle East. Okay. If we have to assess their performance in terms of research, in terms of how they bring some kind of skills in competition, how they win competitions, how they engage in competition outside Turkey, how they may get some research integrity, or maybe they get some research pronouncement. Maybe they are very good in presenting their academic work outside Turkey. Maybe you can find they have maybe around 10%. But if you come to Europe, maybe people, because they have some maybe like they have a language that they can communicate to different countries, not only their own countries. So they may be able to communicate in Turkey, they can communicate in Poland, communicate in Sweden, in United Kingdom, in United States, in maybe even in Middle East. You see, so maybe their impact should be maybe around up to 10%. I'm sorry. So this population is 10,000. Let's assume this population is just maybe around 2,000. But their impact is 10%. This is having, you have 10,000 and their impact is 10%. This you have only 2,000, but their impact is up to 10%. Let's come to this place. These are from where? United States.
Yeah.
Right? Great. So let's assume these people from United States are just only 200. But their impact maybe is up to 5%. You see, you have 10,000 people here, but their impact is only 10%. You have 2,000 people here, their impact is up to 10%. You have only 200 people here, their impact is up to 5%. So if you really want to checkmate your system, you want to checkmate the complete system in this university, so you need to take all this. So if you ignore this, you didn't treat these people honorably, kindly, you may lose your you may lose your university ranking, you may lose your reputations, you may lose a lot of things. Yes. So you know the reason why this 10%, if you can analyze this 10%, you may find people from, maybe let's assume, Syria, Gaza, or maybe Palestine. Okay, not Gaza, Palestine, Syria, Palestine,
Iraq.
Yemen,
Iraq,
Iran, and the rest of it. So maybe people around this place, they are maybe just only out of this 10,000, they are just maybe 1,000. Just an assumption.
Yeah.
But let's come to this. People from This from Turkey, Armenia,
Kazakhstan.
Uzbekistan, and rest of it. Maybe they are up to around 9,000. Okay? So if you want to check their global reputations, global contributions to the university, maybe if you may find this population, they give up to, they are just 1,000, but they can give you up to maybe 5 or 4, maybe, let me be fair. They can give up to 4%, this population. Because this population can be more active, more engaged. They are ready really to give impact compared to this. They are up to 9,000, but they provide only 6%. But this is only 1,000, but they provide 4%.
Yes.
Do you see the issue? So you see, this is the reason why even the minority class has to be treated well. Because the minority class, it should be, maybe it might be the significant predictor in your model.
Yes.
So her column very important.
Yes, of course, very important, very significant. Because it might give you the impact that the dominant class might not give.
Noise data.
Yes, so the only problem is how you can control the noise, how you can try to make the models, how you can guide the models to be one, to treat each samples or each distributions fair, to teach each distribution fair, to look at each distribution is a significant factor in its own modeling capacity or its own modeling framework, like to look at someone from United States, someone from Europe, someone from Middle East, they treat it equals. But the only way they select only those who are very significant. But not because they are the majority, just how they contribute. Recently, I made I developed a models on this health issue. You know one thing, most of the models, existing models, they compared some biological information. You know biology, right?
Biological information?
Yeah, biology. You know biology? Like maybe some biological, like maybe you can say like in baby blood samples, you know blood, right? From our body, maybe blood, saliva, you know, those kind of information. So they found this saliva, you know saliva, right? Doing blood. They found those are the most significant predictors in one specific aspect. But later, I now try to make some kind of strategy. I found monthly visit. You want to go each month. You visit a doctor in the hospital. Each month you visit a doctor. We realize that this is a significant factor. Despite those ones, also this also contribute to build the models. But most existing works just decide and consider those are the most significant factors. They don't look at this. They don't look at how you meet the doctor and why you, they don't care about whether you meet the doctor or not, but definitely they may just only check your saliva. They don't care about relationship between your saliva in this month and your saliva in the next month. You see? Just like now you are sick. You are sick, so you go to Jarrah, right? You go to the doctor, you ask the doctor, I'm sick. Doctor look at your face, he said, okay, you're gonna be okay. He just give you some drugs and ask you to go home. And said next week, you should come. So if you go next week, the doctor must check you again, right? To see what are the severity level of the disease. Is it increasing or is what suppressing? Like is it reducing or is increasing? So we have to check the relationship between the last visit and then the present visit. We have to look at the relationship.
Saliva.
Yes, we have to check the saliva of the last week and then the saliva of this week. Do you see the point? So this is why they are very important. So if you look at these models, we can now see that how we can control this. So look at this. We have this in department as well. if you look at the department, the attrition in the department section, you see you have up to non-attrition. People they may not quit is up to 828, but people they might likely to quit within this period, they are very little, just 12. But if you look at this, distance from home versus employee attrition, look at this, distance from home. Possibilities that because they are far away from their working environment to leave their work or to create attrition, it's not much. So this is the reason why we have to make use of some kind of strategy. Do you see this bouquet? See how it gives a dashboard. Can you see? You can be able to make this kind of so the findings. These are the findings. You can look at the findings from this flow. We can infer that the male employees are likely to leave organization as they amount to. You can see this is bias. You can see because there is possibility of bias because 63% of the males are more likely to cause attrition in an organization compared to female who have only 36%.
I have a question.
Good.
Can we treat the outliers as a bias?
We cannot treat outliers as bias sometimes, but we may just treat outliers as they may lead to bias, but they are not bias. They may lead. Yeah, they may likely to cause a bias, but they are not bias. Do you get the point?
Yes.
Okay. So they may likely. So look at this. You see, you have this percentage. This is 3%, 36%. So in our natural environment, bias exists. But how we can control it, that is the most important point. So you see, we have this. So now we started to look into how we can control this kind of situations. This is just some issues about how this data is treated. Please, you can go and follow these stages, please.
Yes, we do that.
Okay. Ala, please try to do this process.
يعني
What?
تيتشر جروب واتساب مثلا بو موديل شيرينج بو
I shared already, right?
No.
I didn't share it.
Yes, I didn't find it on the.
No, let me show you. I shared it.
I think يعني جروب واتساب شيء important يعني
the-
very important.
For that reason, we have a lot of time to make a step.
You can see this. This is mine.
تمام.
Did you check this?
Last time I checked it.
Yeah,
new.
this is the
yesterday,
service.
but
You can
I
see.
find
It's new يعني بأن
Yeah, it's new. I submitted it yesterday.
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 Because I forgot. You hadn't reminded me. I shared it yesterday. So you can check this. The data set is inside, and then the complete code is also inside.
It's more useful another codes because I checked a lot of codes and
Yes, you can try in another code if you like.
No,
But-
I want this code.
Okay, you want this code, right?
Yes, because I want to make like
Dashboard.
like you, yes, like the course.
So you can, if you open this, you may find the notebook. You may find this. There is this inside, and also there is data set. I also embed the data set inside.
Yes.
So you can also download the data set from this zip folder. So you can try all these things. You can see it by yourself. I don't have to keep explaining. So you see, so this is one step. You can see they try to drop a data set that is not important. Why is it drop? Not data set, some features that are not so significant. This one. Yeah, this one. They try to drop that are less significant. Not because they are minority, no. If you want to drop somebody, so you have to find a way of dropping. You cannot just ask, just drop, just stop. No, you cannot do that. But you have to follow the stages, just as we did. You have to make so many correlations. You have to analyze to see what is the important. Just like in this, you will not just say, I don't like people, I don't care about people to come from United States, or I don't like people to come from Europe. No, you cannot say so. You have to analyze, make an analysis to see what are the impacts of people from Europe, people from United States, or people from maybe other side, maybe South America. You have to assess, you have to evaluate to see their impact. If they really give a positive impact and important impact into your system, so you have to incorporate them, you have to include them in your system. But if they are not important, they don't have any contributions, then you can ignore them. This is exactly what we did here. We did many analysis, right? You can see many analysis, many checking.
teacher, burada mesela evet يعني how system drop information here
how they drop the information.
يعني مثلا كورال فار strategy مثلا work with the strategy
to remove
مثلا impact Middle East تمام
yes, like this in this
analytic var يعني
yes. So after analytic bar, you can use like in this work we use
attribute يعني
attribute features, because this is an attribute. When you say Europe, you can check maybe in Europe, maybe you can say this is F1, so the F1, F2, F3, F4, then this is F5. Let's call all these are features. So what you should do is to try to find the relationship F1, F2. What are the relationships between F1 and F2? Then you can do vice versa. F2, F3, F1, F3, F3, F4. You can see, you can do the relationship. You can try to calculate the relationship. So in calculating the relationship, you can use Pearson correlation coefficient, PCC, or maybe you can use Spearman. You can see. So this is the reason why in this, because we are not building the systems, we are not building the models, sorry, the tools, we just use dev.core. This is because it's an inbuilt package which you don't have to write the functions or to write the mathematics. We did it here. What is this one?
Correlation matrix.
Yes. You can see we use this.
But we didn't drop anything before.
Yeah, we didn't drop here.
Yes.
So this is why they are dropping around this place. This is where it is dropping.
He dropped it about, no, he dropped the iteration because he want to training them.
Oh, sorry. Oh, this one. Oh, I'm sorry.
This
one we remove the level. Sorry, the target. Sorry, this we remove the target. But here we remove some columns. You remember? We remove because we have around 15.
Yes.
15, right? We have around 15 columns, but you see we end up having, no, not this one.
He not removed. I think he utilized, picked up some column.
No, we remove some because these are not, because you see, age, business travel, department, distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sorry. We cannot count from.
I asked you why they choose some column, not the drop. They check correlation matrix to some column up based on what
The relationship.
yeah
Or the instances. Okay, they haven't dropped. Let me check. I want to confirm if they drop or not. Because this is the complete
yes.
columns. Let's count the columns and see. See, we have 35. 35. So they definitely drop some, because like you see, we have over 18 over time.
He dropped this from any stage.
We haven't dropped because you see we have 25. You can see here. Can you see we have 25?
25.
So they drop around 10. 10 columns.
Yes.
Yes. So they drop around 10 columns, but in this place, actually we haven't dropped any feature here. We just drop the target, the class we are interested to map. So we drop only the target. Like maybe in this instance, we are interested about the performance. Maybe we are interested about the performance in the university. So we have to drop the performance. If performance is among the distributions, we have to drop it because it is our target feature.
Yes.
It's our target feature,
It's
performance.
normal.
So then we have to do this correlation to see what is the relationship between this and this with respect to performance. What's the relationship? So after we do all the correlations, we found their relationships, then we can see which ones are less significant.
I want.
You want to write?
No, not right.
Okay.
I studied before, and I think that the correlation matrix, if there a high correlation between two RQs, we should remove one of them. And you told me we should remove all of them.
No, we shouldn't. If like maybe you have, because if you have two like this F1 and F2, maybe their correlation is up to 0.86.
Yes.
Like this.
High correlation.
Yes, high correlations. You shouldn't just go ahead with this kind of techniques. Actually, I shouldn't advise you. You should just drop both of them, or maybe pick up. If you want to pick up one,
yes.
So it's better you should make a what? A further variance analysis to see which one is having the high variance or low variance. You can use this variance inflation factor.
Yes.
Yes. To factor.
You advise me to.
Yes.
Yes. This technique.
Yes, you can use these techniques to see, because if you have two features or two independent variables, but they are highly correlated, their correlation is very significant, because we believe that high correlations in most applications, they may lead to noise in the models and may lead to redundancy. So
yes,
so it's better you should make a variance analysis to check which one is having the high variance or low variance. So from there you can decide and pick up one and drop one. That is why if you check in this notebook, we have some situations. We did this.
He dropped about 10 columns?
Yes, about 10 columns.
Because high correlation?
Yeah, I think so. Because, we check this correlation, if you remember.
I didn't remember we dropped.
What?
I didn't remember we dropped any.
Yeah, we dropped. We dropped some. You forgot last week. Because I don't want us to waste time.
I am sorry, doctor.
No, not on your questions. I mean on the... Yes, if you check like this, you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yes. So this is 26, including this. This is 25. So it's a 25 they maintain, okay? Finding correlation between variables. This is correlation between variables, right?
Yes.
Okay, let's check. Because I know there are some places we drop, if I could remember. Oh, this is encoding.
Doctor, I think this data set a little bit
different?
Yes, because the label in this Excel datasheet it's current manager or not, and from this model the level is attrition.
No, in this data set also. No, this current years with current manager is not the level. This is not the level. Look at the level is at the beginning. You can see this is the level. Do you get the level now?
I'm just confused.
Okay, so please don't be confused. This is our target.
Yes.
So the target is not at the end of the data set. If you look at this notebook, you see. If you look at the notebook, you see, it's the second. Okay, do you get it?
Yes.
So actually, they dropped some. Maybe they didn't consider, because if you look at this in this one, 26. So they have already utilized 26 direct.
Yes.
But
he utilized and he doesn't drop anything.
He utilized. No, he drops some, because look at this. Look at the initial instances, features.
Depends what he dropped. Yes, he dropped there. Dropping columns in the second. Yes.
Yes. You
dropping.
See?
He dropped about.
You see? He dropped daily rate. You can see. Education field, employee count, employee number, you see over. So he dropped this 10.
Yes.
Yes, I know, because definitely this is the same data set. So if we have some missing columns, it means like we drop it. So we drop it from this point.
He dropped about, depends on what? He dropped depends on the understanding.
Understanding of the problem. Yes. So because if you look at this, you see there is this over 18.
Yes.
And it is dropped. There is this relationship satisfaction, which is also dropped. We have standard hours. This one is also dropped. We have hourly rate. Why is it? Why are you guys? This one is also dropped. So, but he dropped this based on his own problem. But if you could remember, he made some visualization before he did this. If you remember last time we checked.
No, I think this started.
Oh, this is the starting point, right?
Okay, so he just think like they are not important, but actually to me, we have to make some correlation before we draw. It's good.
Yes.
We have to look at each feature to see whether it is good or it's not good for the modeling. So let's move quickly to that place.
Yes.
No, it's very important if we understand these principles. So any data set is very easy for us to, and any tools we want to utilize is very easy if we can understand this this environment. Please try to understand this very well.
Yes.
If you understand this very well, if we want to start at the federated learning, because federated learning is very complicated than this one. Yeah, because this is simple machine learning. So that's why I would like you to understand this very well. Yes, because the way we put data in the federated learning is different from this.
Right now, we discover the bias.
Yeah, we are discovering the bias on this normal machine learning.
Visualization still.
Yes. Now the next step, no, we haven't finished with the bias, but we discuss about what we have in the data set. So now the next
we discovered the bias, I think.
Yeah, we discovered, yes, but we haven't handled it.
Yes, handle it, it's the fairness.
Yes, so yeah, handling it is the fairness.
We agreed to solve the bias,
we must, yes, be fair. Okay, so this is, okay, we are in this place. Okay, so we now take our, this one, we take our target variable, so then this is the target data, we call it target data, so we now put it, so this is the attrition. It's just in binary classification because there is attrition 1, no attrition 0, there's attrition 1, so this is how we make it. So then the final features is 25, we have 25, so this is why they wanted to do feature selection.
I have a question.
Okay, what is your question? Don't worry.
We usually, with level data like attention, have disease or no have a disease, to check the bias, we compare all the variables with level data.
We used to do that.
There is bias or not?
Yes, that is why in feature selection or in correlational analysis, we have three kinds of correlation. There is correlation between feature and the features. This is a correlation one. And then there is correlation between feature in the same class and the feature in different class.
Yes.
Let me show you. Let me explain. Please don't be confused. Can I write here? Can I write here?
Yes.
Let's assume we have class 1, class 2, class 3. Let's assume we have 3 class level.
Yes.
And then this is our target.
Yes, and it's empathy right now.
Let's
Is it true?
This is our target.
Yeah.
Okay. Let's assume we have features. We have F1, F2, F3. This is the same thing, F1, F2, F1, F2. Then we have 0, 1, 2. To know whether it is class 1 or if it is class 1 is 0. If it class 2 is 1. If it class 3 is 2. You get the point?
Yes.
Okay. So we can do correlations between feature in class 1 and in the same class. We can do a correlational analysis to see what is the relationship between F1 and F2.
In the same variable?
Yes, in the same variable. So we used to do this. This is the first one.
Then
we call them feature correlation within among themselves. Among the same, they are from the same class and the same column. So we have to check their relationship if we want to reduce the dimensionality of the data set. One. Second, we can do correlation from features in class 1 and features in class 2. This is what we call interclass correlation.
And he did.
Wait, I just want to finish the explanation. So then there is also relationship between features in classes, and then with respect relationship between the features and the class, the target variable. So you have to check the relationship between the features, independent variables, and then the dependent variables. What are their relationship? He did, if you check, he did relationship between dependent variables and independent variables.
Yes.
If you remember, you can see some rows.
With iteration. Yeah.
Yes, with iteration. That is with the target variables.
Yeah.
So you have three ways of doing this kind of analysis.
And we must in the project use all the ways.
It's good. Yeah. In the project you have to, because it is equip you with skills of doing a lot of analysis, and you may get more insight and understanding of your data. So if your data is misbehaving, you may easily find where you have these problems. Is it within the instances, or is it within the features, or maybe it's what inter-features issues? Maybe there is an issue between the targets, your target variables, and then with your independent variables. Like if you have independent variables, they are having high dimensionality with respect to dependent variables. So from there you may understand which one you're supposed to drop or which one you're supposed to manipulate. Because as told you sometimes, it's not important. It's not advisable to drop. Sometimes if we even check for the correlations, we check for the variance, and we found they have, like maybe in some applications, like in engineering applications, mostly in engineering applications, we don't like high correlation in engineering applications. But in some medical applications, they need high correlation.
Technically, yes, that is technically this step in the pre-processing step or the first stage is data exploratory, data understanding.
Yeah, this is data exploratory. This is exploratory.
Yes.
Yeah, because we haven't to make any pre-processing. It is this in this stage we want to do the pre-processing. This stage, feature selection. Yes. Because we are still all what we have did in the past is exploratory.
Yeah.
Because we try to find the insights.
Yes.
We find the insights. We analyze. We see what is in the data. What and what do we have? That is from there. You see, all what we have did is to check the number of instances, number of features, what are the interquartile ranges, and then what are the categorical variables. How many categorical variables do we have in the data, and what are the string? How many string do we have, and where we have the string? This is what we call exploratory. So in the exploratory analysis, we try to find out the insights of the data. So now we are done with that. So now we want to see which one and which one we are going to select based on this kind of tools. Sometimes if features are having high correlations, we have a way of manipulating things. Instead of just to drop, you can do transformation. You can transform. You can use logarithmic transformation, because sometimes if you transform a feature, maybe you have features are increasing, maybe in ascending or descending order. It's based on the kind of information. Maybe you have 0, 1, 5, 25. Maybe this is, let's assume this is F1. This is our F1 feature. Let's assume this is our F1 features. You have 0, 1, 5, 25, 30. You have some variables like this. So sometimes to make a correlation with respect to the target class, F1 and target class, you found that their relationship is very high, or maybe they're having maybe less correlation, maybe 0.01. You see, it's very less, it's much less. Or you can say that it's less significant. Yeah. So maybe you found, and you need it to be at least a little bit, maybe 0.4, 0.3 for you to consider. So you can do some logarithmic transformation. You know logarithm, right? Logarithms.
Yes.
So you can do some logarithmic transformation. You can transform this, or maybe you can use an exponential. You can just take an exponential of F1. Instead of to drop, you can just take an exponential. You can transform. You can do an exponential transformation. You can do logarithmic transformation. You can also do some other kind of, there are many transformations. Like maybe you can do this weighted average. You can take the weighted average mean of the features. You can take the weighted average, then you can do your model. So then the next one is to find which ones are very to drop, on which one are not so serious. So that is why they now mention this. These are feature selections. You should try to learn them, because we have basically we have three kinds of feature selection method. We have this we call them filter method, feature selection. Then there is wrapper feature selection method. Then there is embedded feature selection method. This filter method are based on some statistical information. So, yeah, you can, if you can, we can give like 5 minutes break. Oh, I'm sorry. How do you find the class?
يعني بنشوف very interesting. I love Bo information. يعني University Gaza يعني popularity and teacher أما أنيكي سنة 12 year يعني man worked حتى إنجليزي يعني I work with many company my company يعني my company I need program with other company يعني I work.
So it's no problem. You know, if you want to learn this, so you have to try in your laptop. If you go home, you can open your laptop, download this data set. I provided it. You can download the notebook, then you try all the process. You start step by step.
يعني problem bar. My information shook old يعني very old.
Very old?
A bit.
Oh. You see, how many years? Like 10?
10
10 years?
10 years.
So, but you will try.
I focus
On
يعني now work the money my family
take of your family.
my family إن شاء الله يعني أما يعني I shook interested بوشة.
Yeah, I think if you, because you know now we are in the data science era, in artificial intelligence era, where there are a lot of opportunities. If you learn some skills, some tools, you may work on many places. And also you can also use this kind of strategy. You can get money from company. So it's good. We should keep trying to do this. So, Jazakallah.
جزاك خير.
So let's try to wrap up because today we want to time. Okay. So you can read on your own about this method. Please, if you are interested, you can go and read about this method. So this method is also a little bit more advanced sometimes than this. And this one, we have many methods. I have also my own method here. I also developed a method on this. So yeah, if you want to check my method, you can check it here. So this method is embedded method, this one. So this is my method, this one. It's an embedded feature selection. This is an LSTM, you know LSTM, right? We work with LSTM. Yeah, this one. Let me show you. This is my method. This is my feature selection. You can see it here. So it's my feature selection method, see. So this is my method. Is this one you can train your models with the deep learning, because the feature selection is, I built it inside the deep learning. So you don't have to import feature selection from somewhere. It's just already trained, the same with the layers. So once you are training the models, it is the feature selection is selecting the features while you are training the models. So this is what we mean by embedded feature selection. But in this my feature selection, I trained it, I developed it in the deep learning. So while you are training the deep learning, it is selecting the features automatically. So if you want to see like the complete process, let me show you briefly. If you want to see the complete formulation, this is the complete formulation of my feature selection method. You can see it started from this. You can see this is my feature selection using constant optimization. I built this feature selection method. So this is our class, this is the integer constant, this is the cardinality. So E, this is our classifier of the deep learning models, this one. This is the classifier for the deep learning models, you can see. So this D, you can see this D, we calculate this with respect to this cardinality point. You see this D is the features, the number of features we are having in the model. You see? So then this B of the entire features, the general features of the model. So this one is the loss function. This one is the loss function. The loss, which will try to calculate the difference between the predicted and then the actual values. So this one is the original features in the models, and then this one are going to be the selected features in the model. So this is how we started this. So we prove this. This is how we prove it. Look at the advantage of my method. Instead of to use this PCA and LDA as in this our work, because this our notebook, we are going to use this LDA. So it will, this our method will preserve interpretability because it will tell you which features it's selected. While being trained, while you are training the models, it will show you. So one time I will try to learn that. I will run next, maybe try to remind me. If you want to see how my feature selection is working, I can run it in the class. You can see how it is running. While it is running, the model is running, it will show you the features it is selecting, and it will tell you the number of features it's selected and what are those features. So while you are training, not because you finish, while you are training, it will show you. You are training, it is showing, I select this, I select this, I select this. So it will show you progressively without finishing. Like in the conventional feature selection, you have to finish training the model, then you can see the selected features.
Yeah.
But on my own method, you are training the models and it is showing you, like you are training, you can see the progress of training. Maybe epoch 1 at so maybe this is validation, this is trend accuracy. You can see something like this, right? So in my own method, it will also use selected features. It will also show you selected features at this epoch, at each epoch. At each epoch, it will show you the number of features is selected and what are those features it's selected. So
You
this
select it automatically.
yes, it's automatic. You don't have to touch. You just train. That is why you can see how it is working. You see, this is the proof of the method. This is all proof of the method. So let me show you. We use Turkish data set. This is the Turkish data. So this is the this is the process. You can see the process. So we use a deep convolutional neural network. We take 50 at training epochs. We take this is our learning rate. This is our target feature count. So this is the weight of the models, which we want to differentiate automatically. So these are the classifier. These are selected wavelet basis because I use the wavelet basis to transform the features. I transform my features to become a wavelet basis function. You know wavelet?
What?
Wavelet. We transform. Yes. Yeah, we transform the features to wavelet so that we can get the frequency component, the time component, as well as the spatial and temporal the spatial and temporal relationship of the features, so that the features are more strong and more stable in the application. So this is how you see. This is the training. This is how we train. So this f of theta, you see this f of theta is not just a classifier, it's a classifier with feature selection. So this is a classifier with feature selection. So this will count the rate of change of the loss function with respect to the classifier with feature selection. So this is how we train the models. This is how we transform. You see, you can see many features that are very less significant. If you look at this, so Finally, this is what we call embedded. You see, in my model, you can see the number of features it's selected automatically. Number of features it's selected because I have around, I think, 100 over 200 features, but it's selected 106. So out of 106, the most significant features is feature number 106. Then there is 77, 84, so it's going based on this. The first one is the most significant features, followed by the second one, by the succeeding one, by the succeeding up to the last one. So 91 is the least significant features. It's not important, it's the most least out of this 106.
Doctor, all these methods.
So my method can give you this also. That is why, because we develop an interpretable model. Let me show you. My method can also give you this one. This plot can also give you this plot. It can give you this plot to show you the number of features is selected. So this is all about embedded feature selection. So embedded feature selection, we train the models along with the feature selection. This is what we mean by embedded feature selection. You are training the models simultaneously at the same time with the feature selection. Once the models accept the data, it accepts the data, so the feature selection is built inside the weight of the models. So it will automatically now select some features and gives to the weight and assign to the weight.
Yeah.
And then the weight will start the training. So if it trains, if it's good, then the feature selection will stop. If it is not good, then the feature selection will now collect back and then resend other features.
Yes.
So this is the advantage of this. So it enhances the modeling training, and also it saves computational burden of the models, and as well as the computational time. So I'm sorry, today we take. Okay, this one, right? Okay. So this is what we mean. So there is this lasso. This is the most famous one, but actually in this notebook they use this. Right now I'm not interested in using this. I'm interested in using the inbuilt with deep learning or machine learning because it's more robust to my application. So this is the input. Let me go to the last one. So you see they selected, you can see data selected the shape. You see how many they have selected? 14. After this feature selection,
25?
yes.
If it's 14.
So out of 25, now they selected 14.
Yes.
So they drop 11 features, right?
Yeah.
Yes, they drop 11 features. Because this is how they found. You can remember last time we checked this. You can see the values, you can see based on the variance using this chi-square. They use chi-square and found the chi-square values. So the chi-square values is the scores by each features. So these are the scores. So they selected those with very high scores and discarded those with low scores. So please help me try to do this. So they will now try to get trend validation test data. So they now try to select. You see, they selected it manually, you see?
Yes.
From 0 to 1269, it is selected manually. This is the shape of the input data is 126.9 out of the 14 columns. These are the number of its instances, and then these are the number of columns. Okay? So they now try to create validation. Data is this one. Validation input is this. And then because they remove the target. So finally, I just want to...
They trained that earlier.
What?
Trained that earlier.
Yes, they trained
the model.
Yes, this is how they want to train the models. They just explain you how to train.
With IBM.
Yes, so I want you to register in this IBM because you are a student. You have student number, right? Student code. So you can, if you want to use this notebook, please, you can create an account at IBM. This is the IBM. You can go to IBM Cloud.
This is a task.
What?
This task.
That's
Homework.
What do you mean?
This is homework.
Yes, if you want to utilize this models, you need to create an account in IBM.
Yes.
So you can create your API, because you cannot download this. You cannot download. Don't have the.
This IBM model for machine learning task.
Yes, for machine learning tasks. But if you don't want to use the IBM machine learning, if you don't want to use them, because if you start downloading from this notebook,
I didn't use it before, so I think it's useful to use
Different
model
tools.
with another model and make like a compare.
yeah. So if you want to use this, you have to go to IBM and create a new account. So please, there is an academic account for student, free account. You don't have to pay. So you create your cloud account. Then if you create your cloud account, let me show you the process. First, you have to open this and create an account. There are an account for developers. You can see from there you can get your API. There's also account for products and marketing, something like this. So you have to click here. If you go to login, then you create an IBM ID. Don't have an account, so you create an IBM ID. You see, so you can put your name, if you want to get a free account, use your university email, and then use your student code. So they will give you a free, because there is a free student account. Because I have account with them, so I don't have to like this, have an account. So I don't have to create a new one. I have an account with them. So if you want to use their own machine learning, because you need to, let me show you the process, the last ones. It's my account. Okay, this is my account, you see. My ID. So I don't have to create new account. See, this is my account. These are my tags. So I don't want to authenticate now. So if you open, let me show you something. Because once you download this, once you make this download, if you make this download, you move to the next one. This is just, you downloaded this if you want to download the dataset direct from GitHub. But I have already provided the dataset in your repository. If you don't want to download from the GitHub, it is already inside the zip folder. If you unzip, you can see the dataset. So you don't have to download again. So then if you download, you can see m-attrition.csv. So after, you can install this pipeline level encoder for labeling. You see, for this one. So this is the most important things. So this is where, so this is this AI Fairness 360.
Yes.
This F360. So you can download it from GitHub, in the IBM GitHub. You can see, you can download it from here. Enter interactive experience, or you can download from here. So there are some dependencies they will ask you while you are downloading. So you have to put some dependencies. They may ask you maybe identify the following in the dataset. You can see, so in the advantage of this bias mitigation tools, this Fairness 360 toolkit, let me show you its advantage. It converts your dataset that can be used by bias mitigation algorithms. So before you start the training, you see, we partition the dataset for training and we keep. So now we have to build AIF 360 to see how we can utilize it in the machine learning. So now it will convert our data set to be suitable for bias checking. So then the next one, it will try to do a favorable levels. What are favorable levels? It will level it. Then it will find an unfavorable level. Which level are unfavorable? It will level it. Then it will find a privileged group and unprivileged group. So it will give us 4 kinds of data. You know, we divide our data set into training and validation. So now if we use these tools, so it will now categorize our data set into 4 classes. Class 1, that is, it will try to find unfavorable data. Class 2, try to find favorable data. What is the meaning of this favorable? It will try to find what are those instances in the data. The instances, sorry, not instances, the features based on the instances count that are very favorable to this model, that are favorable, that means they are fair. They are fair, like they are not ready to dominate. Just like in this class, I just come, I look at this. If maybe you are not seeing me, I just pick up your bag. So it will try to look who is in his own position. He is paired to his position. You don't want to dominate. You don't want to dominate your friend. Do you get the point?
Yeah.
So then it will also check for those who are ready to dominate. That is what we call unfavorable class. Then also number 3, it will try to find what? Privilege. What are the privilege? What are those who are they are just privileged in the system? But actually they are not supposed to be in the system, but they are just privileged to be in the system. So they will also label it, and then number 4, it will also label the unprivileged. So this is how it will want to make the data set into four classes. So its gender is the protected attribute. Because if you could remember, gender is not much, especially it is where we are expecting the bias, because the females are not much. Do you remember in the data set, if you check, you can see that the representations of the females are not dominant, are less dominant. So males were dominant. So that is why they now privileged groups, they call it gender 0. Unprivileged groups, they call it gender 1. Favorable level, they call it 0. Unfavorable, 1. You see, this is how it makes this encoding. So we create binary level data set can be used by mitigation. So we now call it binary level data set based on this. So this is the most important point of our lecture, of this class. This point is the most important point. So because you are not familiar with this kind of strategy, right? This is your first time to have a look on this. So I want you to go and do all the first stage up to this point. In this point, you will now download this bias mitigation algorithms. You can check it in the GitHub. If you click, it's available. You can download. You see, you can download it here. So because if once you click on my notebook, you can go direct to this link. You can click on the link because everything is there. I didn't remove anything. I just put, based on how they publish it on the dashboard, I transferred it to your service. So from the service you download, so you can go ahead. All the links, available links are inside, where you can create your IBM account. You can click, create an account, then you can get an IBM ID. So with that IBM ID, and then you can create, if you open, then you search for Watson's machine learning. And the IBM, you can see IBM Watson machine learning frameworks. It is in Watson X. So if you open Watson X, you can see, if you open this place, so you can create, you can see. So you don't have to waste your time to search for what do you call it, for new version. And so if you look at this one is okay. So if you, once you create your account, Once we create your account, so then inside your account you search for IBM Watson's machine learning frameworks. So if you choose, so then you can now create your API. So they will give you an API code. This is where you put it. Because next class I will ask you about your API. This is the reason I asked you, because we need it here. You see this place. You see, you can put your username, that is your username at the IBM, your password at the IBM, then your instance ID. Because once we create your API, you have your instance ID. So you put everything there, then you can put your URL from your IBM, the URL, your link from the IBM. So once you put, so then you can proceed with pip install IBM machine learning. After you install, then you will do this stage, that is import API client. So in this import API client, it will ask you for this UID. You can see custom library UID, client.runtimes.get library underscore UID, custom library. So this custom library is having this UID, but once you create yours, you don't have any problems or any challenge. If really you want to use the IBM, but if you don't want to use the IBM, you just want to use normal standard machine learning, so you can use the standard machine learning from Scikit. You know Scikit? You can go to Scikit library and import from the keras. You can import your normal machine learning. You can import the many. You can import the XGBoost. You can import the random forest. You can import the decision trees anywhere. So then you can do the classification and you do your predictions. But if you want to utilize their own, you have to create your own API there. So I need you to download all those stuffs, please, and then do the data.
Can we see the result? How is mitigation the bias?
Yes.
And fairness.
Yes, this is why we want to run two models. We want to run two models. The first models we want to run without the IBM toolkit, without the fairness toolkit. Do you get my point?
Yes.
So if we run with the normal, once you create your API in the IBM, if you are utilizing the IBM machine learning, once you create your API, so then you download the API, you incorporate, you do the classification without the without this tool. You do the classification, then you record the result.
Yeah.
Do you get the point? And then in the second stage, then we now import this toolkit. You import this toolkit. After I import it, you install it. Then you incorporate it, because you can see how they incorporate it. It's already mentioned there. Prediction plan, elements. I want to see where they put this. What is the name they give to this? You see, in this they use the classifiers use other boost. You can see for the classifier. You use the other boost for the classification. You see, you have the first, you see some result before the last result without the fairness. Okay, I want to see, okay, PM data set. So after they use this data set, you see PM data set, because this is when they apply the fairness. So because this is with the fairness, because you know we already override the existing data set. We override it with the fairness, because you see we created the fairness leveling. So now we give it a BM data set VM dataset. That is the new modified dataset with fairness. Okay, so it is the data you see, the print, the shape. You can see the shape of the training data. One is exactly with the previous one, but training data probable level is this one. Okay, so you see they use metric origin, binary level dataset metric. So for calculating the metrics, so you see difference in mean outcome between unprivileged and privileged. You see, it's you see the difference is less significant between privileged and less privileged, because you see 0.0 minus 0.0 is a negative relationship. So it's not pronounced. The difference between unprivileged and privileged groups. So it tries to balance. There's not much difference between. Because you see, even if there is no this negative sign, 0.01 is very insignificant. Do you get my point?
Yes.
Okay, so negative difference indicate the presence of bias. Refer above link to know more about the working of the algorithms. So now they use this reweighing. You can see 20 up data set levels. This is how they train. So once you make this, if you have any challenge, you can see this is 0.00 metric origin after they did the training. Difference in mean outcome between unprivileged and privileged. So now they mitigate the bias and put 0.00. But in our own case, I want us first to train the models without the fairness. We have to train the models first without the fairness. Then we now integrate the fairness dataset, and then train the models with the fairness dataset and see what are the difference. You get my point? First, if you do this, if you come to this stage, this stage I did.
I will come to you.
once you arrive to this stage. Once you arrive to this stage,
yes.
You see, because we now partition the dataset into train, validation, and test.
Yeah.
You see, we partition it into 3. So once you partition it here,
yeah.
So now you bring the ADA boost, because they use the ADA boost for this. So you can now go to this one. Okay, we have it already inside this. We can have it. So you can check this. You can import from this. Where is? Yes, you can import it from here. You can see ADA boost classifier. You can import from here. You can import this ADA boost classifier and make a classification. What?
ADA boost?
Yes, ADA boost. It's a machine learning algorithm. Yes, it's a machine learning algorithm. So you import it from this, and then you do the classification on this dataset, on this partition dataset. If you have any problem, don't worry, you can send me an email or chat me on the WhatsApp. You get the point? If you have any challenge, this place, right? Why do we have the partition?
There isn't much time left before the break.
Yeah, we are going now. Wow. Sorry. So you can use this ADA boost on this data set and train around this place. Once you arrive to this point, you can train the models with this data set. Please, you can train the models here. After you train, then you now import the mitigation algorithms. You can import this. Then you import. So when you import, this can now make your data set in this format.
Now can you IBM model work it?
Yeah, you can import it. Once you import it, already if you have this, it's not to be difficult. Once you install this.
He used a multiple of machine learning.
Yeah, there are many machine learning models, many.
Yes,
yes, in the idea. There are many because they develop for many countries, many organizations and institutions. You can see some XGBoost, you can see, and also in the SK line, Syscale line, you can import You can see. So you can import from this. You can see there is, each has its own. This one is subscription, but once you registered as a student, you don't have to subscribe. Okay, so we are done. So if you have any questions or concern, please, I like next week is I would like to see a result. If you have any challenge, you can contact me. If you have any challenge with training, you get my point. If you have any challenge with training the models or with the data set or anything, please let me know. Just try. Okay?
Okay.
Sorry today because we haven't started yet.
I prefer to work the project under
Quarter, moment.
supervisor.